Hello everyone here. I want to tell about pre-graded assignment for the course project course, Machine Learning Foundation for Product Managers by Duke University. Now I'll be presenting the step-by-step process that I've used. The scorecard lines that are laid by the project is as follows: that we'll be using will be judged on the modeling approach model, building model evaluation, and model interpretation. The summary, the project topic is here. We are provided with some data set for a combined cycle power plant, which use combined. We use a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. We have a set of 9,568 hourly average ambient environmental readings from sensors at the power plant, which we will use in our model. The data that is provided is as follows. I've segmented the data into training set and validation set. We'll be using the training set to generate the coefficients and use that on a validation data set, and then compare the models. We are using two model here. Model 1 would be with 4 features looking at the coefficients. We'll be dropping one of the feature with the least coefficient, and then create another model with 3 features. I'll move to model building. Just a quick highlight. We have segmented the data into 2 parts, which I've covered earlier. The percentage allocation is purely defined, and the data row counters as mentioned. We are using 2 metric here to compare the model accuracy. One is MC, which is mean square, and second is R square. As mentioned in the dataset we have segmented, we have clearly highlighted each RS as training set and data set to safeguard ourselves from data leakages. So that same data point is not used in both training set and data set. We are using a linear regression model. It is a simple first model to benchmark second. There is very clear correlation between the input and output. You're in the first model. We using all 4 variables, the P is that provided. We have also predicted the P using the Excel regression model. The R square, the multiple R, and the R square is also provided by the same. We have just tried to use correlation and validate that the data that is being used in the model is correct. So then R square that is coming from the model and R square that we have calculated are identical. If you see at the coefficients, the coefficient AP has the lowest absolute value. And that is why in our second model, we have dropped, and we'll be using remaining 3 variable following the same process. And we have predicted DP, and that has also given us some coefficient that we'll be using on the validation set. And then comparing both the models now on our test set, we are using, so what we've done is we have captured both Model 1 and Model 2 coefficients and use it to generate. We have used it to predict the P, both for both the models. We have also calculated the error square, so that we can actually use it to generate the R square and M square error. Now the R square that is generated using the correlation formula for both the models are captured over here. Here we can clearly see that RS is marginally better for Model 1 and MeSQD DARE is also marginally better for Model 1. So we would like to pick Model 1 for our computation. Now, depending upon the objective, we can actually opt for both Model 1 and Model 2, since there is very marginal improvement in Model 1. So if you want to optimize on the computation standpoint, we might opt for Model 2, where we'll be using only 3 variables to generate the output. If we want to optimize for error and reduce the error, then we'll go with Model 1, where the output is marginally better. Thank you.